Hi, everyone. Welcome to Single View of Everything. My name is Kieran Clulow. I'm the Director of Data Engineering and Architecture at IAG. And this is the story of how we've used MongoDB and Apache Kafka to stream 4.4 billion events, which is all the events that come from all the various systems that we have at IAG to provide a single view of absolutely everything about our business. Just briefly about IAG, for people who may not know it, IAG is one of the largest insurers in the Southern Hemisphere, and it has a whole portfolio of brands, including NRMA and CGU that many people would know in Australia and New Zealand. We principally operate in Australia and New Zealand with some small operations in Asia. And then that brings me to the question, why would you want to build a single view of everything? So you can think of an insurance company. Typically, insurance companies grow by acquisition. And as insurance companies grow by acquisition, they start off, as NRMA did 120 years ago, at the beginning of pretty much of the insurance industry in Australia. And over time, they acquire more and more brands. And every time they acquire a new brand, they get a whole new set of systems and a whole new customer base and a pool of different types of policy information and claim information. And it's very hard as those systems accrete over time to get a complete view of everything that's happening over the whole surface of that information flow. So you can think you can be a customer of NRMA who owns a house in Sydney, and you can also be a customer of CGU in Melbourne with a holiday home, and a customer of NZ Insurance in New Zealand with a farm in Auckland, on the outskirts of Auckland. And so we can see all the different people in those customers in those different aspects, in those different brands, but to understand the total picture of what they're doing across all of the different brands is quite difficult to do that matching process. And before we did this project, that could take up to a month to get a really good view across all of our different customers, just because of the volume of our customers, which is a good thing. We've got a lot of customers, but really understanding how IAG is interacting with those customers is quite burdensome. And that wasn't, to be honest, too much of a problem in the past because the brands operated very individually. But as the world, particularly post-COVID, this has become even more important, as the world has accelerated and as the movement from traditional broker-mediated channels to digital channels has been driven, it's become increasingly important for IAG to have a much better understanding of how we interact with our customers, particularly on a digital platform. So whereas before it was reasonably okay if an NRMA customer was treated as an NRMA customer and CGU one quite separately, we now need to understand the interaction with those customers much better across the whole brand portfolio. And so, let's drill into that a little bit more. IAG has a lot of systems. We have information about vehicles across all the different brands. We have customer data pools in all sorts of different MDM systems, but also in core systems that manage policies. And we have policy data in various different systems as well. And some of those systems are quite old. We have systems that were commissioned in the 1980s and are still around, very old mainframe servers that have served us well, but are hard to integrate out of. And then we have everything right up to brand new Salesforce instances. So we have a huge variety of systems and quite a large number of them. I think last count we acquire data from over 170 systems. And so once we've got all this information, we need to combine it and allow us to do modeling and scoring activities on that data. That allows us to build a single view to serve our digital channels via APIs. And the technology set that we looked at doing for this has increasingly centered on MongoDB and Kafka. And the reason for that is that Kafka gives us the ability to take and manage streams of information in real time in order to support those digital channels. It's no longer acceptable for us to, do what I call the bake and cake metaphors, where you get some data and you cook it overnight in an ETL and you put it in a data warehouse and you consume it in the morning. This is much more about, we need to take data in real time and be able to act on it in real time. Because for a digital channel, like a mobile phone app, for example, It's not acceptable to wait 24 hours. People don't even want to wait more than 3 seconds typically. So we need to be able to act really quickly. And then MongoDB gives us the ability to handle data that's not always perfect. You can think of traditionally people have used relational database systems to process data, and that data is quite wide, but well formed with very detailed typing information. But because of the size of the data portfolio that we have, sometimes that data isn't perfect. And sometimes the data will have, one system might have 15 attributes and another might have 300 attributes. And so what MongoDB gives us is the ability to manage that data in a semi-structured way and do that in a very scalable way and be able to scale that information out and increase the processing time. Whereas that was difficult to do to scale those systems with traditional data warehousing approaches. And so then we've got a lot of data, right? IAG is our biggest brand is NRMA, and that's been around for in excess of 100 years. And so if you look at our data, we've got information that goes right back to the 1880s. This is the oldest vehicles that we currently have in our systems that are continuously insured. So we have, a penny farthing motorcycle from 1886. We have quadricycles made by Ford in the 1890s, and Mercedes vehicles first coming in around the turn of the 19th century. And so we want to take all this data, old and new, and we want to tie it all together. And that's really about this digital transformation journey that we've been on for some time. And this is something that's very common now across all of the industries. And we want to be able to take that information and manage it centrally, and then use it to provide not just reports and dashboards, which is typically in the past what data teams would be doing. It's really now about making a product. It's something that we can actually market internally into our organization to drive a whole bunch of different product experiences, and also data journeys. This is our website with our famous koala picture. And so this is really saying here's where we can support those digital journeys both on mobile and on the website. And so what does this give us? It gives us focused insights. Here we've got a record from one of my colleagues, Simon Aubrey, who's graciously given us permission to use his information, because one of the key aspects of all of these things that we do is we always want to keep our customers safe. We want to make their world a safer place. And so protecting their data and using their data in the right way to help them is something that's absolutely core to our mission. So here you can see Simon. This is his activity. So you can see from 2017, he's taken out a CTP insurance policy on a Honda CR-V. He's taken out comprehensive insurance on a 2016 Honda CR-V, lodged a claim for a collision. Sadly, it looks like he's had an accident. He's renewed his CTP insurance. So you can see here already, we're taking information from a variety of systems here and really starting to see the journey of his claims experience and his policy renewal experience through time across all the different brands. So here you can see in 2016, he's had a crash. And we can look at the property factors. So this is his house. It's also insured with NRMA, probably because he gets a staff discount of some kind. And here you can see all the attributes about that property that we know. So we can say he's got a land size of 590 square meters, the slope, the elevation, the aspect, and we use these property factors for things like underwriting. So we can understand, okay, is this property affected by flood? Is it on a very steep slope so that it's harder to rebuild if it burns down? All those kind of rating factors. And then environmental factors as well. We can see here from his house, we can see the nearest educational institute, so probably the local school, the nearest emergency services, nearest shops, what the train station is, it's a 3.3 minute walk away, and even the nearest pub. You'd be interested to know the location of the nearest pub to your house is also a rating factor that we consider. 1.5 minutes away, that's pretty good. And so here we're looking at refocus data. So this is where we say, okay, of those cars that he's listed, Where are those vehicles located? And here you can see over time that vehicle, that CRV, was first purchased. We can see its insured value over time using our single view of asset component of SVX. We can say this vehicle, 2003, was worth $20,000, and you can see here over time it's reducing in value. So how did we build this? One of the architecture first was about how do we take information at high speed in real time from a variety of different systems and pull it through into MongoDB. So the first step is to identify the source systems that we've got. And for our customer data, it's typically like in DB2 databases running on Linux, or in DB2 databases running on Oracle, on mainframes, or in Oracle databases. And so what all those systems do is they have this concept of change data capture. So they have a transaction log that is queryable, and you can read that information out. And so we used a variety of technologies, partly Debezium, but also we use Informatica, IDR to interrogate those transaction logs, take them out and put them into Kafka. And the first step of that is to understand, okay, we've got, you know, a CDC record in itself isn't very interesting because it might say, we do an insert into a column or an update on a column, and its primary key is XYZ, and one record has changed, one column attribute has changed. But we really need the whole record. So we have an architecture called the cleanser, which essentially takes that code, takes that record, and turns it into a full wide record that's useful and queryable, and then we can send that through to MongoDB. And then we have cars that come from DB2 on ZOS. ZOS is a big mainframe server. Policy, as I said, in Oracle. And so then we have a Kafka Connect. Kafka Connect is a technology that comes with Confluent and Kafka that allows us to take that Kafka stream of events and send that through into MongoDB with really just a plug and play approach using this architecture here, this document here that basically says where do we go with this information? How do we connect it through into MongoDB? And here you can see it's writing into the SVA vehicle collection in MongoDB. And so then, okay, we've got all this information in MongoDB. That's fantastic. Then what do we do? So then, if you can think of a customer, for example, we might have customers from NRMA, and we might have duplication in that database. We might have the same customer, Kieran Clulow or Simon Aubrey, who might be in NRMA and in CGU and in still other databases as well. And often the record, because of data quality issues over time, you can imagine in 100 years, you get quite a lot of data quality issues. We have information that might be, you know, K Clulow here, and it might be Kieran Clulow here, and it might be Kieran Martin Clulow over there. They're all the same person, but to get the logic that allows us to manage all that in an automated way without someone having to go and look at every single record is quite difficult, and has involved quite a lot of architecture and engineering time. And the approach that we've taken increasingly is to use Elasticsearch, which we surge out into AWS to allow us to get some scalability. And that gives us the ability to run very complex matching rules that are principally written in Java and then orchestrated using Apache Airflow to take that information and to duplicate that information and merge it using very complex rules that include, you know, Levenshtein distance searches for finding very similar names and working that out. And it also gives us the ability to run different sets of matching rules, because you can imagine you might have a legal match where you need to be very, very sure that the people that you're matching are in fact the same person. So if you're sending out sensitive claim information to them or sensitive policy information to those people, but then you might want to have a marketing search where it's acceptable for that use case to be a little bit less certain, and there can be a little bit of overlap. Say if you're sending information to sets of people without any particularly personal information that needs to go out. And then for customer scoring, we use technologies like Python and R. And then we ingest that information again using Kafka back into MongoDB. So we can take the data, send it off for customer scoring, and then re-ingest it using the same pipeline. So we get that code reuse as well. And then, okay, we've got all this architected, well-designed, cleaned up data that's been customer scored. How do we make use of that, right? And so then we start using these technologies like Mongoose that allow us to take that MongoDB stored data and then send it out for consumption by Node.js APIs, through digital channels through those APIs, and also through dashboards if we want. We actually designed our own dashboards that are served out by Node. And so what did we discover? When we first did this SVX, the first iteration of SVX that I could find on record, which predates my time at IAG, was about a decade ago. The first iteration of it was expected to take about 6 months, and 10 years later, that SVX project pretty much hadn't been delivered. But until we took this new approach of breaking that chain of saying we have to do things in a batch-oriented approach, to moving it to a real-time approach, and to using a much more scalable approach with MongoDB, that really allowed us to accelerate and move much more quickly. And so then we started seeing, those deduplication times come down from anything up to a month long to pretty much you can do that in a few hours, even over customer data sets with in excess of 150 million records. So here you can see we've got a lot of data. So here we've got total messages that we've ingested into the customer deduplication process of 4.5 billion records. So how can we deal with this data challenge? We had this theory that horizontal scaling is something that we can use to address this. So essentially what it does is it divides the system data set up and then sends it out to multiple different servers that we can increase in capacity as we require to. We use Kubernetes to scale out our deployments so that adding extra nodes is really simple and in an automatic way by auto-scaling. And then we use Kafka, which gives us the ability to manage that real-time streaming flow. And here's the reality, right? This is an actual demonstration of this in process and action. So here's some healthy tech competition between the application development team and the platform engineering team who manage the underlying infrastructure. Here you can see, underwhelming. It's time to use more Docker apps. We're only getting 600 records a second with 35% CPU on the stream server. Platform engineering, scale it instantaneously with a click. Here you can see our ingestion stats. Okay, it's getting a pretty bit better to 2 million records. Pretty impressive considering the number of queries and index hits. Looking good on the 16 CPUs. Mongo is keeping up with Kafka on the ingestion side now. Hey, we can bump that up to 32 if you want. Nice, now we're really starting to see this scalability come in. Only 40% CPU usage on the CPUs. MongoDB at this point now starting to drain those Kafka topics out and get ahead of them and pull through. And here we've got a new record, 5,000 records per second, 18 million per hour. So here you can see the team's working really easily, the tooling supporting them, and getting that scalability and throughput that we need to get through that giant backlog of records. Here you have your numbers, 30 records a second, and accelerating up to 33,000 records per second as we start to get that efficiency in code and that scalability and performance. So who participates in the delivery of these features? Here you can see we use Jira, like probably everybody does in these days, to really drive through the feature delivery cycle. And so here we've got a ticket coming through using policy insights here, and then generating addresses and pushing it through to the API, to the end user API. And what does this mean to our customers and our stakeholders? There are things that we just simply could not do in the old days with relational databases. One of these things is geospatial analytics. We have an extremely strong geospatial team at IAG, as you can imagine, because geospatial information is really, really important to do rating and understand flood maps and understand earthquake risk in New Zealand, for example. And so the goal was to really understand the correlations between, say, population growth and policy purchases as the Australian population has grown quite rapidly. And that business problem had been on the table and completely unsolved for 3 years. And so one of the things we used was to take this new architecture of using MongoDB and Kafka and truly try to understand and do an analysis on that very rapidly. So what we wanted to do is we create a duplicated policy map from traditional IAG data systems. It not only involved complex queries, but it's very error prone due to the data quality issues. And because we've done all this deduplication and cleaning and getting all that information in one place, SVX and Mongo brings the power of that data in a single place and allows easy extraction for multiple different use cases. And importantly, it meant that that data was no longer siloed. Typically, you'd have a whole bunch of different analysts, and they'd have very similar, but not exactly the same view of that data. But now, because it's centrally managed and governed, it gives us the ability to have a single view of that data. So here this is a distribution that you can see of policyholders across Brisbane and Ipswich. And here you can see it plotted in 2008, the distribution of people in that area as well. And so what are the things that we learned while we did this exercise? Considerations for success. These are the things that we learned as we went through this process. Large organizations have challenges that impact multiple different business units. And that really leads to lack of clarity on who owns and can solve the problem, which is then also coupled with a general hesitancy about embracing new technology. You can think of large organizations typically have a lot of history and a lot of settled ways of doing things. But modern technology gives you the ability to provide fresh solutions to solve these really old and tractable challenges that have been around for a long time in an organization. And the people who come with that technology help you innovate and provide invaluable support and are integral to project success. And so one of the most important things for the success of this project was having a really good relationship with both MongoDB and Confluent to really bring in the best ways of solving these problems and taking advantage of their experience to sort of lift up our own technology, people, and process. So in summary, we built a single customer view that's been very successful. It's transformed in many ways the way IAG operates. It's gone from being a proof of concept that we were pretty confident about to being one of the most key systems at IAG that drives a lot of value and delivery across multiple different streams of work. We built it using a completely disruptive approach where we went from going from a traditional batch-orientated data warehouse-like approach to a real-time streaming approach. One of the most important things that we did was breaking it down from being just an engineering thing where you give us a requirement, we go off and sit in the corner, and then trust us, we'll be back in 6 months, to being a continuously delivered project that constantly delivered new value and really built a lot of excitement in the business that started to get a lot of code reuse, and you could really see the delivery coming out into the different client teams in digital and in marketing much more rapidly. What does this mean for our customers and stakeholders? As I said, it's really changed the way our stakeholders interact with particularly customer data, but also asset data and property data. And increasingly now we're building it out into policy and claims. So we have essentially a real-time view of policy and claims across the whole organization as well. And it means that we now have the ability to have a much more detailed and structured conversation with our customer base in real time. So when a customer rings us up, it's no longer the case where we go, oh, you're also a CGU customer. We can see that now in real time. And that gives us the ability to really manage that customer relationship much more effectively. Thank you very much for listening to me. It was great to do this talk again. The first time I did this was in New York a year ago, so I hope I remembered most of it. And enjoy the conference. Thanks very much.